Okay, this is a quick review of trigonometric ratios, and they can be used to represent the ratios of sides of a right triangle. So it's important that we have a right triangle, and I've labeled one angle of this right triangle, not the right angle, but one of the other angles, as theta, the Greek letter theta. And the sides are relative to that angle. There is a side that is opposite that angle, so we're going to label that as the opposite side. And there is a leg that is adjacent to that side as well. And then there's another side that is also adjacent. However, it is the hypotenuse of the right triangle. So we have the opposite leg, the adjacent leg, and the hypotenuse. And there is a mnemonic that helps you remember what the ratios are, and that mnemonic is SO, KA, TOA. So remember it in groups of 3 letters. And what that means is that the sine of angle theta is equal to the ratio of its opposite side length over the hypotenuse. That's SOH, sine is opposite over hypotenuse, and the cosine of angle theta is equal to the ratio of the adjacent side length over the hypotenuse. And finally, the tangent of angle theta is equal to the opposite side length over the adjacent leg length. In example 1, we have a right triangle given, and we're asked to find the value of cosine of theta, which is going to be a ratio or a fraction. Now, cosine is the adjacent over the hypotenuse, so we need the adjacent leg, which is the 1. That's our length of that side. And we also need the hypotenuse, which is opposite the right angle, so that is the hypotenuse. So the cosine of angle theta is equal to 1 over 2. In example 2, we're asked to find the sine of angle A. Here's angle A, and to find the sine, we need the opposite and the hypotenuse. The opposite side is 8, and the length of the hypotenuse, which is opposite the right angle, is 17. So the sine of angle A equals 8 over 17. In example 3, we're asked to find the tangent of angle X. So let's find out angle X. To find the tangent, we need the opposite and the adjacent leg. The adjacent leg is the one next to X that is not the hypotenuse. So the tangent of angle X is equal to the opposite divided by the adjacent. And in this case, we should rationalize this result since we don't want a square root on the bottom. So the tangent of angle X is equal to 2 times the square root of 5 over 5. In example 4, we're asked to find the sine of angle B. And to find the sine, we need the opposite. And we also need the hypotenuse. And you'll notice that the hypotenuse is not given this time, but don't worry. We know how to find a third side of a right triangle if we have 2 sides given. We use the Pythagorean theorem, or we can use our knowledge of Pythagorean triples. There is a triple 9, 40, 41. If the 2 legs are 9 and 40, the hypotenuse must be 41. And so we're going to use our knowledge of that to write the sine ratio. Sine of angle B is equal to opposite over hypotenuse, so 40 41st. Okay, in this last example, we're asked to find the cosine of angle X. Here's angle X. To find the cosine, we need the adjacent leg, which is not given, and we also need the hypotenuse, which is 4. Now, it may be very tempting on this one to think that this is a 3, 4, 5 triple because we do have 2 sides of 3 and 4, but For the 3, 4, 5 triple, 5 must be the hypotenuse, so that's not going to be the case here. We're just going to need to use the Pythagorean theorem to find the missing side. So if we want to call the adjacent side a, then a squared plus 3 squared will equal 4 squared. So a squared plus 9 is equal to 16. Subtracting 9, we get 7, and a must be the square root of 7. So the cosine of angle x is equal to the adjacent side, which is the square root of 7, over the hypotenuse, which is 4.